All right, section 1.4 is angle measures. So again, got to review a couple of definitions and things that we started out with in the beginning of the year here. So a point represented with a dot and a capital P. A ray is part of a line with an endpoint. So we have an endpoint right here, and then the rest goes on forever. So we would call this ray AB. A line, you can see a line has arrows on both ends. That means it goes on forever. We call this line AB. Line segment, you can see the dots means that stops. And this is called line segment AB. It's just a portion or section of the line. Just some general definitions to get us started. Now let's formally define what an angle is. Angles are made up of two rays that are not collinear. Remember we learned that earlier, not collinear, not in a straight line. And originate means they start at a single point. So here is the single point that they start with. That's called the vertex. So our vertex of our angle is angle A. You can see we have, this is going to be point B, and AB is a ray, and you can see that AC is a ray. So those are rays that connect at a single point, vertex A, and these lines, these rays actually go on forever. So this angle continues out. If you wanted to continue it that way, that angle would continue. You can see this is forming the side of an angle, and this forms the side of an angle. This is what's called the interior. This is on the inside. We say this is the inside. And anything else, you can see this is the exterior. The original problem, they gave you the exterior way over here. This is also the exterior. So in naming parts of an angle, this would be called angle BAC. You could call this angle A. You could call it angle CAB. Notice when we name it, angle BAC, the vertex is in the middle. Angle CAB, vertex in the middle. So different ways to name angles, parts of an angle. So this is an example using the same thing just on a cleaner slide. So in this example right here, like I said, we can call it angle. You put the symbol in front, angle BAC. Angle CAB. In this case, you can call it angle A, but if there was an extension or another line off of it like this with maybe a D, you could not use this. But in this case, you can, because we're going to assume this is not there. If there's a number there, that also is a way that you can name an angle. In this case, that's number 1. We call that angle 1. We're not going to spend a lot of time on this, actually measuring. But in this example, if you were to use a protractor to measure, and let's say you wanted to find the measure of angle 1, what you would do here is you can see this ray here goes on forever. This is at 0. You can see the numbers start to increase going this way. The other ray is at 30, so angle 1 would be a 30-degree angle. If you went from angle 2, again, you would start here, you would go to here. Again, let's say you wanted to find the measure of angle 4, and this was angle 4 right here. Angle 4, you would start at 0 and you'd go the other way. That would be 60 degrees. Okay? Some formal definitions here, classifying angles by measures. Acute. Acute is the measure of an angle that is less than 90 degrees. Obtuse, an angle whose measure is greater than 90 degrees. A right angle has a measure exactly equal to 90. Straight is 180 degrees, made with two opposite rays. Here's an example right here. And if we say something is congruent or congruency, this right here reads, two angles are congruent if measures are equal. So 30 degrees equals a 30 degrees. Those would be congruent angles. So now we get to some classifying and naming of things to see how we can do with interpreting information. Question A up here says to name all the angles have B as a vertex. So the first thing you have to do is you have to find B. B is right here. Okay, B is this point right here. Okay, so think of different ways to name B. And these are some of the examples that we get. So we can call it angle 5. We could also say that's angle GBE. So angle 5 is equivalent to angle GBE. So is equivalent to angle 5. Now, another way to name the same angle. We have angle 6. Angle 6 right here. That another name is that is angle EBD. It's another way to name angle 6. Angle 7 is right here. Another way to name that is angle DBA. And you can see over here there is no number. So you have to use the letters. They use the angle ABG. So lots of different ways to name things. This example right here says name the sides of angle 5. Well, here's angle 5. What makes or forms angle 5? Well, it's right here and it's right here. Those two rays form that side, or the sides that form that angle. So you could say BG, you could say BE, you could say BF. Any of those are going to work. Then it says right here, write another name for angle 6. I already covered that. There's lots of different ways to go. Those are different ways to name that. We don't measure and classify a lot. If you had to, these are some ways that we could do that. So we have angle TYV, TYV. So that would be this angle right here. What you can see is this is a straight line. This section's 90. So what's left out of that is 90. That makes that a right angle. Angle WYT. So WYT is right here. Now again, if you don't have a measuring to use that, you kind of estimate 130 or obtuse. And then the last one here, angle TYU, TYU, that's this section right here. We would estimate that to be about 45, which is a cube. Now we're going to use some of those concepts, and a very important one actually coming up here is called an angle bisector. So we have a ray that divides an angle into two congruent angles is called an angle bisector. So in this example over here, we have PQ. So PQ right here, that is called an angle bisector. So that's a very important definition. PQ is an angle bisector. So it takes this angle right here and cuts it into these two are now equal or congruent angles. We like to use the concept part plus part equals whole. So what do we mean by part plus part equals whole? That means that this part plus this part equals the entire whole angle. So part plus part equals whole. But by definition here of angle bisector, they're stating this section plus this section is equal. Why? Because we have an angle bisector. Bisector cuts things into two equal parts. So let's try an example here, folks. In the figure, it says that QP and QR, so QP and QR, that's just telling you they're opposite rays. With, if you remember from definition, that now tells you that PQR is a straight angle, or 180 degrees. QT, so QT is right here, bisects angle RQS. So it takes this angle and cuts into two equal angles. So we have the measure of angle RQT. So here's RQT. So this is 6x plus 5. And measure of SQT. So SQT is right here, 7x minus 2. Well, since this is an angle bisector, it cuts those into two equal parts. So when it says down here, mark the picture, that's what I just did. I marked the picture. So now what we have to do is we have to set these two equal to each other, 7x minus 2 and 6x plus 5. Those two are equal. Again, why? Because we are told that we have a bisector. That is an QT is a bisector. So now we do algebra to solve, but again, notice what they're asking you for. They want you to find, they give you these two things here, and then it says find the measure of angle RQT. So RQT, they want you to find the measure of this. In order to find that, we have to solve for x. So subtract 6x. X minus 2 is 5. Let's get x by itself, add the 2. So we find that x is 7. So when we find that x is 7, we now can plug that into the expression. So this is our expression. So we have 6x plus 5. We just defined that x is 7, so 6 times 7 plus 5 right here. So 6 times 7 gives us 42, plus 5 we know that the final answer is 47. 47 is going to be the measure of angle RQT. Now again, from that, we know if this is 47, we know that this is equal, so that's also 47. If we had to find the entire angle, what would we do? We would add those two up. 47 plus 47 would give us 94. So that's if they ask for the whole thing, which they will down the road. Next slide here, same type of concept. In the figure JM, so here's JM here, is an opposite ray with JH right here. So again, ultimately that's a straight angle. Those two are equal. I mean, no, not equal. Those two would add up to 180. It says right here, NJ, so here's NJ, bisects angle M. So here's MJO right here. So this bisects. Now I know that a lot of you are saying, well, these two aren't equal. Okay, well, that's the best picture I could work with. So I just tried to make a problem that's reasonable. So in this example, we're going to assume these two are now equal. Why? Because NJ bisects that angle. So just by that definition, we know that this angle equals this angle right here. They give us that MJN is 3x plus 14. And they give us that OJN is 6x plus 2. Says find the measure of angle. We want to find the measure of angle MJO. So that's the entire thing. So again, what do? Algebra. Set those two equal to each other. 3x plus 14 equals 6x plus 2. Subtract 3x. 14 equals 3x plus 2. Subtract the 2. So we have 12 equals 3x. Divide by 3. We find that x equals 4. So again, now we have to go back and see, well, what did they ask for in the problem? What did they ask for? They want the measure of angle MJO. Here's MJO is the entire angle right here. So we have to find one of the two angles. So let's just say we use this one right here. So 6x plus 2. X we know is 4. So 6 times 4 plus 2, 6 times 4 is 24, plus 2 is 26. So if this is 26, this is 26, add those two up, 26 plus 26, final answer is 52 degrees. So again, that's where we have to use the part plus part equals the whole. Part plus part equals whole. Last example, I want to try one more, see if you can do this one on your own. If not, or try it, and then you can compare with what I get. So QP, QR, QP, QR, opposite rays, straight angle, 180 degrees. QT is right here. QT bisects angle RQS. So there's RQS that is bisected. So now we know that this equals this. We should be able to take a look and figure that out. So in this example right here, it says find the angle, find the measure of angle TQS. So this is what we want to find. If RQS, so that gives you the whole thing. This is 22A minus 11. Again, that's this whole thing right here. 22A minus 11. And they give you that RQT. This section is 12A minus 8. Now this one's a little bit tougher. Why is this one tougher? Because they give you the whole and they give you one of the parts. So you have to think, well, what do we know about these two? Well, these two are equal. So some people like to double that. Some people just like to write it twice. Let me write a little bit. So 12A minus 8. You have two of those. Plus 12A minus 8. So part plus part equals whole. The whole was 22A minus 11. So again, part plus part equals whole. So we have to set those two parts together. So now we simplify. Now we have an algebra equation. Simplify. 12A and 12A, 24A. Minus 8 minus 8 minus 16 equals 22A minus 11. Now we're just solving algebra here. Subtract 22A, subtract 22A. So we have 2a minus 16 equals negative 11. Add the 16. So we have 2a equals, that gives us 5. It gives us 5. So yes, we're going to divide by 2. And a is 2.5. So sometimes you do get decimals. And in this example, what do they want us to find? They want us to find the measure of TQS. So when we go back up here, how are we going to find TQS? That's this section right here. Well, you know this section with that expression, so now we have to plug it in. So we take this 12a minus 8. So 12a minus 8, and now we plug in the 2.5, so 12 times the 2.5, and then we're going to subtract 8 from that. So in this example, 12 times 2.5 is going to give us 30. 30 minus 8 is going to give us 22. So in this case, our final example, or final answer here, is going to be 22. Hopefully that helped you out. Again, if you need to look it over, look it over. Great job on the notes.